In this video, I'll show you how to solve the ALEKS problem called writing the Lewis structures for a molecule with resonance. The first thing that we want to do in this problem is count up the number of valence electrons in our molecule, which is NO3-. And to do that, we're just going to add up the number of valence electrons for each atom. Here's a reminder of how many valence electrons we have in each one of the atoms based on this location on the periodic table. Our nitrogen atom is in column number 5. That means that nitrogen atoms each have 5 valence electrons. We have 3 oxygen atoms in this molecule. Oxygen is in column number 6. So that means that there are 6 valence electrons in each one of the oxygens, 3 times 6 because we have 3 oxygen atoms. And then don't forget, when we have a negative charge like NO3-, we need to add 1 electron to reflect that negative charge. If we have a positive charge here, we need to subtract an electron to reflect the positive charge. So this molecule, NO3-, has a total of 5 plus 18 plus 1. That's a total of 24 valence electrons. And that means we're going to need to use all 24 of those electrons when we draw its Lewis structure. Now it's time to start putting the atoms together. Looking at the molecular formula, the first atom in the formula is going to be our central atom, and then all of the other atoms in the formula, the 3 oxygens, those are arranged around the central atom, initially connected with single bonds like that. That used 2, 4, 6 electrons. So we've used 6 electrons right there. That leaves us with 18 more electrons to go. Again, it's just a process of what's the first atom in the formula, that's what you're going to put in the middle. All the rest of the atoms, even if they're not all the same, they're all going to go around the central atom, connect everything initially with single bonds. Now, the next thing that we want to do is take these 18 electrons and use them to satisfy the octet for the outer atom. So we're going to work only on the outer atoms to begin with. I'm just going to start with the left-hand oxygen and then work my way around. This oxygen atom currently has 2 electrons in that bond, which means in order to get an octet or to get 8, we need to give it 6 more electrons. So now the oxygen atom has 2, 4, 6, 8 electrons, and we just gave it, like I said, we gave it 6 electrons, so that means we have 12 more electrons to use. Now we're going to do the same thing for this oxygen atom. It currently has 2 electrons. It needs 6 more. 2, 4, 6. So we've given that guy 6 electrons, and that means we have 6 electrons left to work with. And here's our last oxygen atom. Same thing. It currently has 2, so we want to give it 6 more to get it up to 8. And that means we've used up all of our electrons. We have no more electrons to put into this molecule. That doesn't necessarily mean that we're done. We should always then look at our central atom, take a look at that central atom and see how it's doing in terms of its octet. The nitrogen only has 2, 4, 6 electrons around it, but it wants to have 8. It needs to have another set of electrons, but we don't have any more electrons to give it. So in this situation, what we're going to do is take a lone pair from any one of the oxygen atoms, and we're going to move that lone pair into the nitrogen-oxygen bond to make a double bond. We could do this literally with any oxygen atom. So we could take this oxygen atom's lone pair and make a double bond right here, or we could take this oxygen atom and make a double bond, or we could take this one and make a double bond. When we have this kind of situation, when we could do it here or here or here, that's when we know that we have resonance. And what we have to do is draw all of those possible situations. So what I'm going to do is let's just start with this one. Move that lone pair to become a double bond. Doesn't change the number of electrons, we've just moved it. The oxygen atom still has an octet, 2, 4, 6, 8, and the nitrogen atom now has an octet, 2, 4, 6, 8. So that's one structure. Now we need to show that what we did here could have also been done with this oxygen atom instead. So what we're going to do is take this resonance arrow tool, we're going to hover over the oxygen atom on the left, and it's going to pop this resonance arrow button into place, and we're going to redraw this structure in this position right here. Now ALEKS is kind of quirky about this. It wants you to draw whatever atom is right here next, which means we're going to have to draw this oxygen atom next, and then we can connect the nitrogen and the 2 oxygen atoms to it as well, like that, sort of in that order. And what we want to do is redraw this particular structure, but instead of having the double bond in this location, like let's have it in this location instead. We just want to draw in a different spot. So it'll look something like this. And then we're going to have to repeat that one more time because remember we have this third option of where the double bond could be located. Use the resonance arrow tool again, hover over that oxygen, click it into place, and then add your oxygen atom and your other atoms like that, and fill in all of those lone pairs. In this last structure, we're having the double bond over on the right-hand side of the molecule. Looks like that. Now, because this is an ion, the last thing that we're going to need to do is fill that charge in. So what you're going to do is click on this box, and if I remember correctly, it's going to put individual square brackets around every single one, automatically put it around every single one, and you're going to add a negative charge on every single one.